decided to go to Votech. Remember that? Votech?
Oh, exactly. There's a stigma.
Yes.
Whereas if you go to Switzerland, I remember going to visit my sister in Switzerland back in the 90s. Plumbers playing foosball next to lawyers, next to doctors, next to carpenters.
It doesn't matter.
It doesn't matter because everybody's happy.
Right. One of the happiest places I've ever been is Nepal, right? It's caste system. I'm not saying it's good or bad, but whether you were a street sweeper, or you were in the army, or
Respect.
They did.
Respect.
Right? That was your deal, and you did it.
It was your contribution to society. Your contribution, how you contribute. I want to bring up an interesting point that was voiced back here, one of your classmates. This is pretty mindless, just plugging into a machine and getting an answer out, and I understand that. The interpretation of what it means is more important, and I want to come back to that. But we started to read into what the data was. So you see these negative 14s, negative 34s, 16s, and so forth and so on. One of the points was, well, wait a minute, those numbers are kind of meaningless. Like you look at one of them, like, oh my god, negative 34, holy crap. You look at one, it's like, holy crap, negative 9. And David's concern was, wait a minute, what was the initial? You know, maybe they had extra 34 pounds. It should have been on there, and this took care of that. Possibly, yes. That's a good concern. Something else is, can we attribute all of the weight loss and/or gain strictly to the diet? Maybe, if the experiment was conducted correctly. But what if the people that did the negative 34 and the negative 38 and so forth and so on amended their routines with vigorous exercise, where some people didn't? Well, that would be called an uncontrolled experiment, and you got to watch out for that kind of stuff. In 244, we'll talk about it. You want to make sure you're controlling every element of the experiment except for what you're controlling, or except for what you're studying, which in this case is the meal versus meal replacement. So, more on that in 244, but it bears mentioning right now. Very, very good. All right, what do we got? What do we got? Are we losing weight?
Negative 14.7.
Negative, that's your average?
Yes.
So we got an average loss in pounds. Negative 14, can I call it negative 15? That's okay. Just to make the numbers easier. We'll have tricks for dealing with decimals, obviously. Good. So we're doing good. Alan.
But the standard deviation is 16, so some people gain a point.
So here's the challenge. Thank you, Alan, and thank you, Vivica. I think both of you guys were going to tell me that. So without the data in front of you like I have, and just so you know, it's very hard to get raw data like this. That's why this is an 06 study. I haven't found anything more recent, because raw data is hard to come by.
WS stands for weighted sample.
WS.
What's
Loss.
loss? Sorry.
Oh God! Sorry.
No.
No.
Your other one, your bottom ones.
Equals a 16.
Looks like Swiss, but there. Sorry.
There we go. Now it looks like sloths. Sloths. So the problem without talking about a standard deviation is you can do this and say, look, on average you're going to lose 15 pounds. And that's exactly what happened in your sample. On average, 15 pounds were lost. The problem is, as Alan correctly pointed out, there are a few that gained. So what do you think? Let's suppose this was the meal replacement group. Let's just throw that out there. It doesn't matter if it's meal replacement or the edited diet. Does this diet make you lose weight or help you lose weight?
It can.
It can. How much?
An average.
On average of 15. Now that's the problem. Yes, both of those statements were 100% correct. It can help you lose weight, on average 15 pounds. It can also help you gain weight. So the question is, can we, I mean obviously, right? It can. Now the question is, can we metric it in some way? Can we say, okay, the average was 15 pounds of weight loss, but is there a way to metric it in some way? What's one way you can metric this? Does this diet help you lose weight? Forget the average for a second. What's one way of looking at it?
How many people lost weight?
Out of 35,
More people lost weight than...
more people lost than gained. Good. So at least the majority. Can we get even more specific?
Yeah, it's
You can count them up, can't you? Use your last project. Good. What you got, Pat?
7 people gained weight.
7 gained, which means 28 lost. So there's a 4-to-1 ratio of lost to gain.
There was 1 0 that didn't gain.
There was 1 0 that didn't gain or lose. I'm going to still call it 4-to-1 if that's okay. That means there's an 80% chance of weight loss. Now that's one way of looking at it. 80% chance in a sample, you'd have to put a plus or minus on that, wouldn't you? You couldn't just leave it at 80%, it's plus or minus something. But that also agrees, unless the margin of error is 30%, with more lost than gained. But what that doesn't tell you is what? What doesn't that? 80% lost weight, plus or minus. But what doesn't it tell you? About the weight lost?
Doesn't tell you how much they lost.
Doesn't tell you how much. So there's nothing wrong with the percentage. It actually is a nice way to preface it, like, oh, in this study, 80% lost weight, plus or minus. And now we're going to go into talk about how much was lost. So on average, 15 pounds. The kicker is, okay, what percentage lost between, say, for example, I don't know, within 5 pounds of the 15? Now remember, friends, in general, you're not going to have this in front of you. You're going to have that in front of you. Is there any way to derive any kind of meaningful percentages from just those two numbers? And the answer is yes, believe it or not, depending on one thing, Pat. And watch this. What I want to do right now with you, friends, I want to graph this data. I want to make a histogram on this data. Yeah, by itself, Pat, no. There's not a whole lot you can do with this by itself. But if you look at the data, and the data is shaped a certain way, then you can make a conclusion based on it. Let's take a look at it. So, fire them up. Fire the machines up. Go ahead, Dot, yeah?
How come, how do you know